Not like last week where I was the only one with sound. I think it's fine this week though because I can see the desktop audio bouncing around. So right, okay, we should, in theory, be live. And I really hope we are this week. And I hope everyone can hear me. Give me a thumbs up in the side chat if you can. And I will hand you straight over to Baldy Catz, who will run you through the form for this evening's event.
Yeah, I'm really looking forward to this one. It's a really meaty topic of climate change. I'll let the two people introduce themselves, but you'll understand why I'm really excited to see this. So we're going to have 4 rounds as usual. The opening round will be a chance just to make our opening statements. There'll be a rebuttal round, and during both of those rounds, as usual, your opponent will be muted. Then we'll go back to the question, the back and forth, which I'm sure will be kept really, really civil. And then we'll be taking questions from the chat to ask both of you. Now, at the end of each round, we'll be putting a community poll up and giving you the chance to decide who you think has won that round. But please don't go and just vote for the viewpoint, the opinion that you agree with. Please vote for who you think has presented their case best. It's a bit of fun. Who's been the best debater, if you like, rather than the topic that you agree with. And I'll mention more on that after the end of the first round. I'm just going to get my stop clock up. Before we start the first round, I'll just give the two people we've got here a chance to introduce themselves. Tony, I think your face will be more familiar. So I'm going to allow you to go first on this one. And thank you very much for coming on. So, yeah, just want to introduce yourself, tell people a little bit about you.
Hi, I'm Tony. I'm from Australia. I'm a geophysicist, and my work is loosely related to climate change, but I studied it in quite a bit of detail as a result of a sort of sustained political controversy.
Brilliant. And so how many years would you say experience in climate change science would you say you've knocked up now?
I started studying it in earnest in 2012, so I've been studying it for the last 8 years.
And guest number 2, I've got one name for you on email, one name for you on the screen, so I'm just going to let you introduce yourself. Thank you for being here.
Thank you very much. My name is Buen. I'm from North Macedonia, and I'm currently studying electrical engineering.
Brilliant. And so you're undergraduate still?
Yeah, it's my 4th year, but now with the coronavirus, it's like a little bit a mess.
Brilliant. How's things going over there?
Not great. We had a little bit of break with the infected. Now we have like 101, but it's a small country. Like we're like 1.5 million people. So
great. Now, if I may just very quickly summarize each of your stances before obviously you expand on that debate, just so people know specifically what this debate is about. Bojana, and I'm going to pronounce that wrong all night, mate. I'm sorry. I'm going to try lots of different. You tell me like when I get close, but Bojan, yeah, is that no?
Bojan.
Brian. I will get there.
Slavic name, yeah.
Brian's stance is that climate change is somehow linked or affected or caused by the Earth's magnetic field, but I'll let him expand on that. And I think Tony will be telling you what his stance is in the opening statement. Tony, would you like to go first?
Sure.
Or would you like Juan to go first? Or
no, I'm happy to go first.
It's okay.
You happy?
Can I just step away from the computer for like 30 seconds?
Of course you can.
Just need to.
Of course you can.
Okay, back in a moment.
We'll just see if anything is happening in the chat. If anyone has got questions, just like I said, that you want to answer you want to ask the debaters in round 4, if you just make sure you post them in the community poll that I will put up at the end of the first round. Creaky, have you seen anything in the chat you want to respond to?
No, but it's interesting you just said about the questions, because I literally, it's just come like a light bulb over my head what I think I'm going to do for future debates, and I'm addressing obviously the people involved in the debate and the people watching. For anybody who used to watch my Q&A live streams, I used to have a Google form in the video description. And the way that works is anybody who wants to actually ask a question can submit it via that Google document, and then it appears on screen for us. So I think going forward, that may be a better way to organize the receiving of questions from the side chat. So I'll try and get that set up ready for next week, and I think it'll make it a little bit easier for us to organize the questions and try and avoid missing any.
Superb. That sounds like a good idea. Now, where were we? We were gonna go. We were gonna go for it with
Tony's
Tony.
ready to rock and roll. Tony, when you're ready for your slides, you just let me know, and just as I said to you in the email, you just give me the number of the slide, and I will pull up the appropriate slide as we go through the debate.
Mm-hmm.
All right. So I'm going to make an active case. I'm not just going to oppose the electromagnetic theory. I'm going to make the active case for why carbon dioxide is a greenhouse gas, and it is physically impossible to increase carbon dioxide concentrations and not increase mean surface temperature if all other factors are kept the same. Now, I'm going to start by briefly discussing what I mean by climate. Climate refers to mean meteorological conditions on timescales of 30 years or more. Anything shorter than 30 years is a form of weather and is not climate. These variations are often used to try and dispute what is happening, but they're not at all relevant to discussions of long-term climate. What I'm going to present here is a summary of 200 years of scientific investigation in something like 10 minutes. So I'll be skipping over a lot of stuff, and I'll be simplifying a lot of discussions, but hopefully it will remain intelligible to people. So if you could bring up slide 1, please, Creaky. The story starts in 1827 with a guy by the name of Joseph Fourier, who developed a lot of the mathematical formalism that we use for heat transport. In 1827, he asked a very simple question. One of the sorts of questions that sounds so absurdly stupid that you wonder why anybody would ask it. Could you go into slide 2, please, Creaky?
Yep.
And the question was, what should the temperature of Earth's surface be based solely on energy we receive from the sun? And the answer he got was actually very profoundly different from what he expected. Now, today I'm not going to replicate his results because he had some very complicated observations based on the temperature of the moon, temperatures during eclipses. I'm going to come at this from a modern perspective, which is a little bit briefer. And the point we're going to start out is that the energy that Earth receives, it must radiate out. Broadly speaking, conservation of energy applies. That little formula there describes the energy that Earth receives. So S is the amount of energy received from the sun. For Earth, that's about 1,373 watts per square meter. That A term is the albedo. That's an important term. It's the amount of energy that is just reflected away from Earth. It doesn't get to Earth's surface to be transformed into heat. It's just reflected away, and it's due to ice, clouds, ocean, whatever. For Earth, that's about 0.3. Pi r squared is just the area of the Earth that's facing the incoming energy. Could you go on to the next slide, please, Creaky?
Yep.
So that's the energy in, and the energy out. That's actually, energy in is fairly intuitive. Energy out is is a bit more complicated. It uses what's called the Stefan-Boltzmann law. That sigma term there, the first little round letter, is the Stefan-Boltzmann constant, experimentally determined. TE is called the effective emission temperature. It's measured in degrees Kelvin. which is relative to absolute zero. And we don't know that ahead of time. It has to be solved for. And the entire surface of the Earth is radiating this energy, and that last term is the surface area of a sphere. So we have our two formula. We can solve for TE, and we determine that T is about 255 degrees Kelvin, which is minus 18 degrees Celsius or 0 degrees Fahrenheit. But if we look at Earth's mean surface temperature, we see that actually its surface temperature is 288 degrees Kelvin. So based on energy from the sun, what this result is telling us is that the Earth should actually be very, very cold. So have we screwed up here? Are we wrong? Have we made some false assumption? Could you go on to the next slide?
Yep.
And the observations tell us that no, we aren't wrong. If we satellite missions that measure the radiation output, the radiation budget of Earth, show that that the Earth does radiate energy consistent with being 255 degrees Kelvin. So that's a very odd result. The surface of the planet is a lot warmer than you might expect. Next slide, please, Ricky.
Yep.
So so we can also do the same sequence of calculations for other planets. And Venus is one. It has an albedo of 0.75. It receives solar energy of 2,622 watts per square meter, around about. So its effective temperature, it's 178 degrees Kelvin, really, really cold, like that's a minus 95 degrees Celsius. But its surface temperature is an eye-watering 740 degrees Kelvin. That's insanely hot. But anyway, so this has the same effect. Now, surface temperatures atmospheric temperature profiles on Venus were accurately predicted using radiative transfer models, where CO2 is treated as a greenhouse gas, and they were later confirmed by satellite missions to Venus. It's also worth pointing out that Venus has no magnetic field, so this warming effect at the surface cannot be caused by electromagnetic fields. If you go to the next slide, the person who did the early work on determining the atmospheric temperature profiles for Venus was Carl Sagan in 1962. This work was later confirmed by the Venera satellites in the late 60s, 67, and so on. Next slide, please, Creaky. So what's going on? This cartoon here, which I hasten to add is nowhere near being to scale, shows a satellite well outside of Earth's atmosphere looking down at Earth. Now, if it's looking down in the visible spectrum, it can see all the way to Earth's surface, and we've seen spectacular photographs of what Earth looks like from high satellites. But if it's looking down in the IR spectrum, it can't see the surface. That's what that low emission temperature is telling us. So it only sees one optical thickness into the atmosphere. It sees down to that red layer, which I've called HE. That's the effective emission height. For Earth at the moment, that's about 6.5 kilometers into the atmosphere. So once IR energy gets to that altitude, it basically expects to get to space without being absorbed and re-emitted by any of the atmosphere in between. If you go down to the next slide.
Great.
But if we make the atmosphere more opaque to infrared, then that altitude moves higher. The satellite outside can't see as far into the atmosphere, but temperature increases as you move lower in the atmosphere. So that temperature horizon, that fixed temperature horizon HE, has been moved higher. That must result in an increase in surface temperature. Now here I've shown the change in temperature with height as a simple gradient, and it's more complicated in reality. But this is just a cartoon to schematically illustrate what's going on. Okay, so is carbon dioxide a an IR absorbing gas. Next slide, please, Creaky. So the IR absorption characteristics of all of the gases are meticulously catalogued as functions of temperature and pressure and atmospheric composition, and they're presented in databases. The most widely used, well, HITRAN is the data set that sort of the global community has decided to settle on, and all global spectrographers use that. And you can take the HITRAN data set and you can validate it inside the atmosphere, as that second paper there is showing. Now we move down. Could you go on to the next slide, please, Ricky? So this is a slide showing the Earth's infrared emission spectrum as observed by satellites. Now that red line at the top is what it would look like if the Earth was emitting at its surface temperature. That blue area underneath is what's actually being observed, and you can see that it's lower, and the peak is actually set a bit to the right, and that's consistent with the lower emission temperature that we mentioned earlier. But you can also see that there are big gaps missing out of it, and that's due to the infrared absorption of the various greenhouse gases inside the atmosphere. Could you go down to the next slide, please? In this slide, we're looking at model values for the infrared emitted into space by Earth using the HITRAN values and plugging them into a radiative transfer model. The black line there represents the total greenhouse gases. The red line represents if you only have CO2. The blue line, the blue line represents if you turn CO2 off. The red line represents if you turn water off, and so on. That plot on the right-hand side shows the absorption of the various greenhouse gases. So that red line is water, the blue line is CO2, well, the pale blue line is CO2, and so on. Could you go down to the next slide, please?
Just to in terms of time, I did forget to stop my stop clock. I think we've probably got about a minute and a half left just for the intro. Just
no problem.
Give you a heads up.
Okay, so we have this theory, we have this model of how greenhouse gases but can we turn it around? Can we look at a warming pattern and say, is this due to a greenhouse effect or is it not? And it turns out that we can. This diurnal asymmetry is basically meaning that actually what we expect, because we're changing the rate at which energy is leaving Earth, we expect nighttime temperatures to actually get warmer faster than daytime temperatures, because nighttime temperatures are impacted immediately by how fast the heat gets away. Sorry, now I'm confused about which slide I'm on. I may have gone advanced. Are you still on the two graph slide?
Tony.
Okay, number 12. I wish. Yep. Okay, number 12. Okay, and go down again. So this graph shows the top is the daily temperature range, which is the difference between the maximum and the minimum temperature. The second one is the maximum temperature, and the third one is the minimum temperature plotted for the time period shown. Now you can see that the maximum and the minimum temperature are both increasing, but the minimum temperature is increasing faster than the maximum temperature. These results are for the continental United States. There are some geographic variation to this, but the general pattern is the same. Nights are indeed getting warmer faster than days. Next slide, please. The second symptom of greenhouse gas, of the greenhouse effect, is stratospheric cooling for complicated reasons involving infrared emission. to space, we expect the high atmosphere to cool. Go down to the next slide. And that's exactly what we observe. Here we're looking at two time series of observations compared to climate models during the satellite period. And you can see that the stratosphere is steadily cooling over this period. Next slide, please, Creaky.
About 30 seconds.
So what I hope that I've demonstrated is that Earth does have a greenhouse effect, that planets that don't have a magnetic field do have a substantial greenhouse effect, that CO2 is a greenhouse gas, and that it is impossible to increase the concentration of a greenhouse gas and leave surface temperature the same as long as all of the other factors are unaffected.
Brilliant. Packed full of information. Creaky, do you want to summarize all that?
Not really, no. I'm starting to get a headache.
It was very, very good. I was, lots to take in there with that one. That was extremely well prepared. So thank you, Tony, for that. Really, really appreciate it. And I'm going to pick your brain about some of those things offline at some point as well, if I may. Now, did you spot anything in the chat? I've been...
nobody's actually sent any questions through yet, but nothing much going on, I'm afraid. Not yet, anyway. Maybe everyone in the side chat's got a headache as well.
I was having good. It was good. It was good. I enjoyed that. Thank you. Now, Juan, did I get that right this time? I hope.
Kind of.
Oh, almost there. Right, if I'd like to take in, you'll get your chance to try and rebuke anything Tony said in the next round, but this is just for you to present your case and so this is your time. Forget anything Tony said. This is just your time to present what you think, and then we'll do the rebuttal in however long. I did forget to stop my stop clock, so I'm not going to be too strict on the time. I'm not exactly sure how long that we went for that. So off you go. Whenever you're ready.
So yeah, first let me thank you for inviting me to the chance to speak. Second, thank for my opponent for the input. So I've been researching this for at least 5 years since it began like a very major populated with so many people who want to say that CO2 is the main reason. When I get the interest, I was because it affects my profession. So it's mainly because of the electric plants we have. So I started researching that because it affected my job. And what I found that I don't agree with the major consensus on climate change. Does climate change happen? Yes, of course. It's natural to happen on the planet. It varies over time. So can Creaky please open my presentation and go to page 8?
Page 8.
Yep. So this is not my videos. I have taken this information and it's all in the link in description in the PowerPoint presentation. So as you can see here, what is normal climate? Normal climate, this is in a years of 500 million years ago. You can see that the planet was much hot. It's normal for the planet to be hot. Now we're in the ice age of the planet. So the explanation of this is they say that 50 million years ago, India collided with China in Asia and created big mountains, and rocks absorbed much of the carbon. So carbon dioxide is affecting the climate change. That's non-disputed, of course. But does now we have enough carbon dioxide in the atmosphere to produce some major changes in the climate change? That is my point. when they are calculating with their computer simulations about the climate change, they in their formula they are not taking the water vapor, which is 90% of uh, how the climate works. So if you take something that 90% affects the formula, how can you be sure that that's not going to change everything? Many factors as oceans, El Nino, over time it builds heat in the ocean, then releases it. That affects too. And I think, for the most part, that what is affecting the planet is the solar seasons of the sun and the Earth magnetic field. Earth magnetic field has been decreasing in strength uh, due to, I think, this is my theory, so I'm not some scientist, I'm just studying this. I'm studying electrical engineering, I like magnetism, so I started going in depth in this. And quickly put on the page 6, please.
Great.
So this is the North Pole, or magnetic South Pole. This is the magnetic field has been around in Canada for, as far as we know, 200 years. We know that it was in Canada. So now it started shifting. In the last 100 years, it started shifting upwards to Siberia. So we predict that the magnetic field stayed in Canada for a long time. It's not normal for the magnetic field to have changing this much. So the magnetic field is going very high speeds to the Siberia. They say maybe it's a magnetic reversal of the poles. Maybe it's many theories. We don't know anything about the magnetic field because we don't have research now for the magnetic field. It's not research as it should be. The mainly reason why NASA has researched the magnetic field is because with their telescopes and satellites in orbit, they were affected by the so-called the Atlantic anomaly. Can you go quickly on the presentation too, please?
Number 2.
Yeah.
Great.
So this is the Atlantic anomaly problem. So the magnetic field here is much weaker than it should be. It's around in the world on average 5 microteslas. Here is about 1 or 2. It varies. So when they sent the Hubble telescope, it fried his electronics, and they needed to go to repair it because here the magnetic field is much weaker. And then they began to research magnetic field intensity. So can you go quick in the first line?
Number 1, yeah.
Yeah.
Okay.
So this is the UV radiation in the world. I have here a link of article that is posted in 2014. This is link in description. It says that in Peru, on a mountain that was high 6 kilometers, they measured UV radiation, and they found out that the UV radiation is about 43 index of radiation. So 43 is a pretty much big number for UV radiation. In the many cities now in Peru, the beaches are some of them may be closed because they say that it's 12 UV index, so it's very risky to go in the sun in the beaches. So what I'm trying to tell that maybe the climate change with the solar activity of the sun, because now we know, I think now in 2012, 20, the magnetic field of the sun is going to, the season of the sun is going to be on solar minimum. So now we should be getting lower temperatures in the next years. We can see the changes in the nature already. Like my trees now, they have been giving flowers until this month. That in the previous years was in March or April. Now it's like 1 month later. So the nature is feeling the change of the sun, and now we are going to go to less solar activity in the sun magnetic field. So that means less radiation, less energy from the sun, and the planet should be cooling. I mean, I hope so. Why do I want to research this? Because it affects my field of work. They are proposing some solutions, let's say, like solar panels, wind turbines, alternative resource for energy, but they are not effective. That's why, can I ask Tony, does in Australia, because I've heard over past years that in Australia you have blackouts, and the electricity is very high in price. Tony?
Are we in the conversation section?
No, I just wanted to ask you a question.
Okay. So, yes, there are occasional blackouts. Yes, Australia has very high energy prices. I can explain the economics behind that if you want, but it's a complicated political minefield.
Yeah. So that's why I started research this, and I don't believe that is major changing. The CO2 is a major change in the climate. So what I'm trying to say, I watched Human Dyson. I think you may be familiar with him. He's a physicist and mathematician. So he said that yes, we are producing CO2, but does it that bad, like they say? Is it good or bad? Well, you can have, if you're producing more CO2, vegetation will become richer. So in average, the vegetation from the past 36 years they have done research has been increased like 20% in the whole world. That's average. So if you have greener planet, mean that you will absorb more carbon dioxide. We still don't know what is happening exactly with the planet, what is affecting all these changes, what is how is that beneficial if we put CO2 in the atmosphere? Is it great? Is it bad? How much bad? I'm done.
Okay, thank you, Bojan. Bojan, I will get there in the end. That'll be my mission for the night. If I learn one thing tonight, it's going to be how to pronounce your name. Right, I'm going to leave you with Creaky while I go off and I set off the community poll for who you think won the first round in terms of how well they presented their side of the argument. If you've got any questions that you want to ask either the two panelists, can I just ask, and I'll keep reminding you through the show, that if you, for tonight, place them as a reply to that first community post I'm about to put up now, then I'll just have them all in one place and I won't be searching through the chat. So I'm going to create that poll and I'll leave you with Mr. Creaky Blinder.
Right, I think my headache's easing off slightly now. Listen to everybody in the side chat. If remember now, when Catz has put up the poll, you're not voting for which side of the argument you agree with. You're voting for who you think presented their argument the most comprehensively, the most professionally, whatever you choose to call it. But this isn't a question of ganging up on Bojan or Tony. This is a question of you deciding, and remember, it's just a bit of fun, you deciding who you think presented their argument to your liking. Would that be fair to say, Catz?
Well, and that post is now up now, so you can get voting. You can leave any questions for later on. Round two now, so you get to have a little bit of a rebuttal from what against what your opponent said. We'll start again with you, Tony, and I will start my stop clock this time, and we'll set it for about 6 minutes.
Okay.
So 6 minutes for you, Tony, to refute what Bhuwan said. Then we'll get into the back and forth. Okie dokie.
Okay,
So my stop clock is going.
Okay, Creaky, can you bring up slide 20?
Okay, on screen now.
Okay, so on geological timescales, the ocean floors spread, and as they spread, the crystals in the rock on the ocean floor record the orientation of the magnetic poles of the Earth. This is a schematic of that process occurring. It's just a cartoon. If we go to slide 21, this is observational validation of the conceptual model showing ocean floor magnetic striping as detected. Now, if as detected by geologists, if you could go to slide 22, please. Now, if geomagnetism is a primary driver of climate change, then there ought to be a strong correlation between these magnetic reversal events and observed temperature, and there simply isn't. This is a correlation for the last 5 million years that shows the magnetic striping, and on the top there is the Delta 018 benthic record, which is a temperature proxy. So there's no obvious pattern here going from North Pole to South Pole, or going from long polar reversals or short polar reversals. There's just no correlation here. If we go down to slide 23, this is a 65 million year. This is a 65 million year climate record, again derived from Delta 018, correlated on the bottom with magnetic stripe reversals over the same period, and you can see that there's just no systematic correlation between magnetic reversals and climate. It just doesn't seem to be there's no evidence to support the existence of the interdependence that is being claimed here. I have put a red stripe at about 55 million years to illustrate an abrupt spike in the temperature record up the top. And you will note that there is no corresponding magnetic event in the bottom figure. This is called the Paleocene-Eocene thermal maximum, or PETM. Could you go down to slide 24, please? So here's a detailed isotopic analysis of Delta 018 and Delta C13 for the Paleocene-Eocene thermal maximum, and we can tell that there was a large influx of carbon into the atmosphere and a corresponding increase in temperature. If you could go down to slide 25, please. Here's a series of ocean floor cores. The arrows show the initiation of the Paleocene-Eocene thermal maximum. This is the point at which benthic forams became extinct, and you can see that rather than the sediment being dominated by their shells, which are light, it becomes all muddy and dingy because there's no organisms there to process it and turn it into. So there was a global extinction event during this. This was a CO2-induced warming that was 100 times slower than the warming we're currently seeing. If you could go down to slide 27, please. Or we could look at the Permian-Triassic extinction event, which is also known as the Great Dying, for the benefit of those at home using Google. If you could go down to slide 28. This event was again caused by a massive outflow, by significant global warming caused by an introduction of greenhouse gases into the atmosphere. This was the result of lava being intruded into carbon-rich sediment, as illustrated in this diagram here. Now, we don't have infinitely many Earths on which to do a statistically significant scientific sample, and nor do we have the time that it would take to do those experiments. So what we do is we look at episodes in Earth's history, and we try and reconcile them with what we know about physics. And there is no evidence in the paleoclimatic record of the magnetic field strongly influencing climate, but there are several episodes, and I've only scratched the surface here with two of them. There's the faint young sun paradox, or how Earth escaped snowball Earth events that we could discuss. In fact, if you go to slide 29, this is what the Earth should look like nowadays without a greenhouse warming effect.
About
and
30
again,
seconds.
okay. In fact, in its history, Earth has been in several snowball Earths. It only escaped because of carbon dioxide. If it weren't for carbon dioxide, we would still be in one of these states.
Yeah, that was bang on. Bang on to the second, that was well timed. Well done. Right. Mr. Creaky Blinder, anything you've spotted that is worth?
I am just, I've been keeping an eye on the side chat. There's nothing obvious jumping out there, but being the genius live streamer I am, I still have not opened up the community tab to have a look what's going on there.
Well, I for one, I'm definitely learning loads here with this tonight. So thanks to both of you for what you're doing. One, you've had a chance to think about Tony's opening statement. Are you ready to rip it apart, sir?
Not rip it apart. I'm just here to make a conversation. I don't want to get and argue with someone.
Oh yeah, no, it's a term that we use in Northern England. Like, it's a friendly term. So off you go, buddy.
Okay, so I don't know if you understand me, but I was not saying that the magnetic field only is affecting the planet. There are many factors that affect the planet that we get to a situation like now. Who does the carbon dioxide now that is in the atmosphere, does that correspond with what we see now with the temperatures? So you said on the first presentation about Venus, or I think it's Venus. It has, yes, because of too much greenhouse gases, it's very hot, and it doesn't have magnetic field, but it doesn't have vegetation. So if it had the same vegetation as we have now, would we be like now? Because when we are not now prepared, I think that's the correct answer, to say this is the major reason why the climate is changing, and we need to do something about it, because we don't know what is happening. Honestly, if we are speaking, we think that carbon dioxide has some role. It has, but how much? Does this number gonna change that much? Because we have increasing vegetation, other planets don't. If the vegetation is increased, then maybe the carbon dioxide will get less of a greenhouse effect. Water vapor is out of the equations when they make these calculations. So carbon dioxide is not disputed that it's changing, but is it in our situation now that much big of a problem? The other statement I want to make is about the planet. The political agenda now is going on with the electric power plants burning too much coal.
I'd like to object to that.
What time are we? Hang on, just thinking, because you've got about 3.5 minutes left, and then we'll go straight into the question and answer. So if Tony, you save that question just for the next 3 minutes, and then you can start the question and answer straight on that point. How's that sound?
Okay.
Yep.
Yeah, carry on, bro. Go on.
What I was trying to say is that we don't have enough sufficient technology today to change the production of electricity. If we change, if we use solar panels or wind turbines, they're not effective. I don't know if you know, but the wind turbines are killing too much birds. Solar panels are not effective. You need to cover entire fields, open fields that are for farming with solar panels that will not going to produce too much. They're helping inputs in the electricity. So if you need to have about 70% of constant generating energy, and energy is not calculated in megawatts or everything. You need to have to put a power plant into operational. You need to have the right frequency. So if you don't have the right frequency, you cannot put it into the system. It's not just about how much it produces, it's about the frequency. How much frequency is that? So we we don't have now that they can be used. I only say the solar panels can be used in the households to help, but for other reasons, for mass production of electricity, it cannot be used. Many countries tried, like Germany. They they invested so much into making electricity from alternative resources. They wasted so much money, and they are getting so much little. Like in Australia, you're gonna have blackouts because you don't have constant sources of electricity. It's gonna be expensive also because it's not cheap to have solar panels, wind turbines, and it's much complicated than it looks like we can solve if we don't burn fossil fuel. Thank you.
Okay, fantastic. Well within your time as well. I've put the poll up for round 2. Should I hit post on that, Creaky?
Yeah. There's a few questions come in underneath the results for round 1. Are we going to reveal that now, or are we going to wait until we're a little bit further in?
Well, we can reveal the result for round 1. The questions, I think, if I save those for round 4.
Yeah,
but yeah,
absolutely fine.
What do you want to do? I think in other weeks we've just revealed it.
Yeah, we've revealed round 1 at the end of round 2, round 2 at the end of round 3, and so on. So the results are in for round 1 with 89%. We have Tony, and that leaves Boan with 11%. And that doesn't mean one has won and the other one has lost. It just means that more people were in favour of Tony's presentation style.
However, Buan, I will embarrass someone called Call of the Void, who didn't leave a question to ask, just said that you were cute. So, there you go, mate. I'll pass your phone number on. So I never get anyone saying I'm cute, Creaky. I don't know what it is. Maybe it's about that, like, what's this middle-aged Lancashire man in his 40s? Like, what's not attractive about that? Who's losing his hair and putting a bit of punch on? I never get it. It's not right. What about you? Must be inundated with comments like that.
Oh, absolutely. I can't turn around without adoring people drooling all over me. I wish.
It's hard work, isn't it? But no, there you go, Baran.
It is.
Right. So round, if you do want to ask Tony or Baran a question, please put it on the poll, on the community post for the round 1 poll, because that's where I'll look for all the questions. We're going straight into round 3, which is the back and forth. And I know Tony has a point that he wants to start that on that you mentioned. Are you happy and we'll just start the conversation there and see how it goes.
Okay, so a couple of times this conversation has moved into the political response and the energy policy response to climate change. That's completely irrelevant. That has nothing to do with the science of climate change. whether or not geomagnetism or carbon dioxide is causing warming is irrelevant to policy response. That's a completely separate question. And quite frankly, you seem to be coming into this with a narrative. You have a narrative, and that's the prism that you're viewing all of these results through. I'd like to correct two things that you said. The first is you said that the models don't include water vapor. That is categorically false. They do. And if you think they don't, then I suggest you need to review the literature more carefully. The models that I presented in my presentation clearly did include the radiative effect of water vapor. Water vapor, however, cannot be a driver of long-term climate change because its lifetime in the atmosphere is too short. But the other point that I would like to make is that yes, the planet is getting greener. That generally means that there's more algae in the oceans. That's what greener generally refers to. Humans aren't algae, and they don't eat algae. So that isn't actually a response. Now, it's worth pointing out that only 50% of the carbon dioxide that humans have emitted has ended up in the atmosphere. The other 50%, 25% of it has gone into the oceans, and 25% has been absorbed by plants. But there's only so much space for plants, and further, they will start dying if temperatures go out of their fall outside of their range. So you can have carbon that has been sequestered in plants that gets re-emitted later on, and this is a factor. Why are you ignoring nuclear power?
Because they want to close all the nuclear power plants.
Who's they?
Germany is closing them from the Fukushima.
Okay, but
Fukushima happened.
But that's. But you said that we don't have the technology to produce. We do.
Yes, we do. I didn't have the time to finish, but we do have nuclear. But that's the only alternative we can use. And the nuclear power plants are now being. I mean, the history of humans in Chernobyl.
But that again is a policy issue, right?
Not quite, because the price of power plants has risen so much that the countries cannot afford them. Like big countries, they need so much money to build a nuclear power plant because of the restrictions they have from the society.
Well, but again, that's a policy decision, not a science decision.
Yes, but
and that is something you said earlier about requiring the 75% carriage all the time. That's only true because of the way we've structured the energy market. If we structured the energy market in a different way, that would cease to be true, right?
What? Excuse me? Can you repeat?
So you were talking about the requirement of a base load in electricity production.
Yes.
That is only a requirement because of the way the market is currently set up.
Not quite, because to have for you to produce electrical for you to produce from a power plant, let's say a country needs.
Yes, sorry. That's exactly my point. Because we're dependent on power plants with particular characteristics, our market is set up to respond to those power plants.
Yes, but the point is, if you have a stable system that's always changing, let's say.
How can it be a stable system and always changing?
Because a stable system is because it's controlled, and it's controlled with stable electricity production with constant frequency. If you put in, let's say, 700 megawatts in power station into operational mode, you need to reach a certain frequency to enter that. If you don't have it, you cannot put the power plant into a production mode. So if you have one turbine solar panels that are always changing, like not gonna be clouds, not gonna be so much wind. You will need to change, put them and get them out of the system all the time.
Yeah, but that's
So you need
a
a
market
constant-
change.
No, that's not a market change. They cannot produce the frequency to put it stable. So if you have a thermal reactor, you're gonna boil it, the water, and you're gonna produce 700 megawatts on 50 hertz all the time. But if you have a changing system of solar panels and wind turbines that are always changing, they are gonna need you need to change very much. And if you don't have enough wind turbines, you're gonna have blackouts like you have in Australia. That's a very big problem.
I think you should be very careful making statements about the Australian energy market.
Why?
Because it's a very artificial market. The reason energy is so expensive in Australia is because the federal government, in order to get all of the states on board, gave the states the right to profiteer their pricing system. So the energy companies that are largely state-owned have been profiteering the loopholes in the regulations that they themselves wrote. That's why our energy market is so expensive.
I understand that. I didn't say anything about the pricing. I said about the blackouts. You have
yes, but the blackouts are a result of the pricing.
No, it's not about the pricing. If
yes, it is about the pricing.
The power plants are not running out of money. They are running out of constant frequency.
No, they're what they're doing is they're rerouting power to markets that will pay them more for it. So Adelaide is experiencing blackouts because the power stations are sending their power to Victoria, not to South Australia. That's not a result of the factors you're alluding to. And interestingly, it's actually a consequence of climate change because it's getting warmer. People are putting more. People are using more air conditioning. They're using more. They're using more energy, and it's a self-defeating system. You cannot say, look, And also, I just want to ask a question: how long, if we stopped emitting carbon dioxide tomorrow, when would the planet stop warming?
I don't know.
Okay, about 50 or 70 years from now. Okay, so your claim, you're basing your position on, well, it isn't that bad of a problem yet. Maybe we should wait for a little bit longer before we start responding. The system has a considerable amount of inertia. It's going to keep warming after we stop producing CO2. So once we decide that things are actually catastrophic enough that we should stop doing this, the problem hasn't reached anywhere near its most intense level. So what you're suggesting is actually very irresponsible. You are taking an enormous risk.
Listen, I understand, but the point is, we don't know for sure that carbon affected. The mainly thing that affects the planet is the orbit of the planet and the sun.
We do. Creaky, could you bring up one of my slides?
Yeah, absolutely. Which one, Tony?
Okay. Slide 33.
Okay, fire away.
Okay, so this is a comparison. The red is the observed change in temperature. The grey is the natural, is what the climate would have looked like under natural forcing. That is only natural forcing factors that we're aware of. That's the sun, that's volcanoes, that's that sort of factor. Panel B is anthropogenic. That's the result of aerosols and black carbon and greenhouse gases. Now, neither of those on their own do a good job of matching the observations, but when you put them together, you get a very good fit. Now, if our model of carbon dioxide forcing were wrong, then that wouldn't happen. You cannot claim that we don't have observational validation for our model of carbon dioxide forcing. We do. If you take carbon dioxide forcing, you cannot do hindcasting. Could you show slide 32? Okay, this is slide 32. This is one article about hindcasting of climate models, which is taking climate models and using them to cast previous climate change. And this is a very large component of how climate models are tested. They are thoroughly tested. They are repeatedly being assessed and reassessed and recompared against the observations. You've made the statement several times that we are uncertain about the role of carbon dioxide and natural forcing in the climate system, and that is simply not correct. The scientific literature is replete with tests, and I would point out, so you've been doing this for 5 years. Have you been doing it full time, researching climate change?
No, but let me finish. I don't know why you're getting angry. I'm only pointing.
Okay,
let me finish. I'm pointing only that science need to consider all other options, not to be like close-minded. Oh, it's just the carbon and it's okay. We need to search for all the options that is on the table, not just overlook something. I said the sun, seasons of the sun, and the orbit of the planet is the major changes of today, changing climate. But today, I mean, these recent years, like 50 million, let's say, years. It's because major of the sun and the orbit of the planet. Thus, carbon is affecting.
That statement is false. Did you know that statement is false?
What statement? Of the solar, the sun not affecting the climate change?
No, of planetary orbit being a dominant feature. Okay. Creaky, could you bring up slide 19?
Okay.
Okay, so what you're referring to is the Milankovitch cycle forcing of the glacial cycles, correct?
Yes.
Okay. Here, the contribution of Milankovitch cycles to Earth's radiation budget is assessed. I have highlighted the section. The fraction of the record variance attributable to orbital changes never exceeds 20%. In no case, including a tuned core, do these forcing bands explain the overall behavior of the records. The remaining 80% of the forcing comes from positive feedback mechanisms, in particular carbon dioxide and albedo. So your statement that orbital forcing is dominant over carbon dioxide is incorrect. Carbon dioxide produces about 40% of the observed radiative forcing during the glacial cycles. Milankovitch forcing never exceeds 20% of the glacial cycles.
Tony, sorry to interrupt both of you there. Can I just ask, genuinely, because I don't know, so I've got a feeling, that a lot of people watching don't know. Can one of you just explain what a Milankovitch cycle is?
Okay, if you go to slide 17.
Okay.
So this is a plot of temperature and carbon dioxide for the last 800,000 years. which are dominated by glacial cycles. These were recognized. You can see those peaks there are interglacial periods. They're very brief, and then you drop down into a relatively long glacial cycle. They're about 100,000 years long. What happens is that tiny gravitational perturbations due to the gravitational effects of Jupiter and Saturn and so on have an effect on the ellipticity of Earth's orbit and its axial tilt, and there's one other factor that they influence, but these turn out to have complex interrelationships. But it's actually not the gravitational forcing itself that does most of the work. It's the feedbacks that amplify this glacial forcing. So if you go to slide 19, for instance. So most of the carbon dioxide on the planet ends up in the oceans. As you warm the planet, due to, say, this Milankovitch forcing, that reduces here we're looking at the solubility of carbon dioxide as you raise temperature. So as you raise the temperature, carbon dioxide becomes less soluble. So the carbon dioxide that is in the oceans basically gets kicked out of the oceans. And this is why the carbon dioxide levels follow the temperature levels. But once it's been released, the carbon dioxide amplifies the warming signal. So it provides its own warming signal on top of the initiating warming signal. And that's what makes the glacial cycles as intense as they are these two positive feedbacks, one being carbon dioxide and the other one being CO2.
Thanks. Right, sorry, I didn't mean to interrupt the discussion there.
That's okay.
I just needed a clearer picture. That's great. Go on, Brian, you carry on, mate.
Yeah, Creaky, can you please open my presentation and go to slide, let me see, 12.
Slide 12. Okay, fire away.
So this is orbital variation with correlation with the temperature. So when they are this confirms the Milankovitch cycles. Of course, that as you said is correct, but it has a major effect on the planet.
Less than 20%. Less than 20% of the yes. I am perfectly prepared to concede that the Milankovitch cycle provides the initiatory mechanism, but it requires significant positive feedback in order to drive the cycles. Correlation of frequency does not, in and of itself, demonstrate that you're getting the magnitude right.
Am I right? So, and I'm interrupting again. I'm not asking a question. It's just so I can clear up that I understand what you're saying. Are you essentially saying this cycle causes mechanisms on Earth like the evaporation of carbon dioxide from the ocean, and it's that positive feedback, and that's right, and it's that's causing the global warming, and its own little positive feedback loops.
So it goes positive in both ways. So as you as you warm the Earth, you release carbon dioxide, and you also melt the ice sheet, so you reduce the albedo, and that provides further warming. But it also makes the planet more hospitable for plants, and the plants soak up the carbon dioxide. And this all happens quite slowly, and you reach an equilibrium position, and then you get a downward trend where you've got increasing ice sheet coverage, more albedo, that makes it colder still, and you kill off plants. The solubility of the carbon dioxide into the oceans increases, and and so that again feeds back into the cooling mechanism. But that all relies on the process being very, very gradual. If you look back at if you go back to my slide 17, you will see that sort of those look very, very sharp. But if you go to slide 16, you can see that the recent addition of carbon dioxide into the atmosphere is positively stratospheric. It's it's not even a close match to natural variation. And we can do statistical analysis. We can demonstrate based on the statistical character of the climate that the current trend has a probability of less than 1 in 3 million based on what we know about climate change, about the planetary climate overall. Yes, it's possible that modern science is wrong. It's possible that there is some physical mechanism that behaves exactly like carbon dioxide exists that just happens to be correlated with carbon dioxide levels. But that possibility is simply not scientific until you can demonstrate it, until you've got an actual causal mechanism. And that's one thing that I feel like you failed to present, was an actual causal mechanism between geomagnetism and climate. I don't think you presented a strong physical argument for why that is the case.
First, this is my first debate. I never done it, so it's my first time. Second, I'm not a scientist, and I would like to in the future to research more on this, of course, when I finish my university. But the thing is, I only said that this could affect it. The sun, the sunspot of the sun are doing are hitting the planet. The other thing is now in Japan they measured after the Fukushima, they measured the radiation in whole Japan. So what they find out, when a lightning strikes, it has radiation, solar radiation in the planet, in the place where it struck. It's about 1 minute, I think it lasts, the radiation from the sun. So what I'm trying to say that, Creaky, can you please open up my presentation and go to slide 13?
13.
Yes.
Great.
So this is from a video from YouTube from a guy I watched. He says that the planet Earth is behaving like a capacitor. So what it means that the planet is neutral. The ionosphere is highly charged particles, so it's a positive. So when you have clouds, there is an insulator, and when you have clouds, they can contribute to exchanging between ionosphere and the planet. So that's why maybe it's happening in Japan. We have solar radiation in the planet. I mean, inside when.
So why has this never happened in any of the previous magnetic reversals?
That's what I was trying to get to the point now. So you said that there's no correlation between the climate change and the magnetic field when it's reversing. Yes.
Yes.
But I'm not saying that when it reverses. I'm saying when the magnetic field weakens. It doesn't mean that it's gonna reverse.
Okay,
The,
so you said that's nonsense. That there's weakening of the magnetic field ahead of every reversal.
yes, but sometimes
So there should be a corresponding climate signal ahead of every reversal.
no, because it doesn't mean that it's if the magnetic field is gonna weaken, it doesn't mean that it's gonna reverse.
Yes, but a reversal requires a weakening.
Yes, but it doesn't mean that it's gonna reverse.
What I think he's. Oh, sorry, no, I won't put words in your mouth, Tony. You crack on.
Okay, so you seem to be having a difficulty, and perhaps it's linguistic. What I am saying is that ahead of every reversal, there must be a weakening of the magnetic field. If you
That
are
is correct.
suggesting that weakening of the magnetic fields causes a severe climate response, then ahead of every magnetic reversal, there should be a massive climate response. Because there is a weakening then. Now, you can claim, I'm not suggesting that you're claiming that we're going into a magnetic reversal now. What I'm claiming is that for every past magnetic reversal, there should have been a change in climate. And we don't see that.
I understand. The point is, when we see back, we cannot say on certain points. Maybe the weakening. I mean, this is a theory. This is not proven. I'm not a scientist that researched this. I'm just giving more views on this matter. So, what's the point? If now the magnetic field is causing some change in the climate, it's not maybe major, it's maybe amplifying the other factors. As I said, it's not one factor like carbon dioxide or magnetic field of the planet. It's the sun, the oceans, the everything in the planet. We don't understand enough climate so we can claim that one is the thing or the other.
Have you read a climate textbook?
No.
Then on what basis do you make that statement?
Papers. On my own research, on papers, on what I written.
Okay, well, I dispute your conclusion.
It's okay. I'm here just to talk, not to get in some agreement.
May I make a point about? I'd just like to make a point about scientific debate, if I could. Do you know the history of the greenhouse gas theory?
You can tell me.
Okay.
I'm familiar with it.
The idea of anthropogenic greenhouse gases was first proposed in 1896 by a guy by the name of Svante Arrhenius. And at the time, it was widely rejected. He invoked it to try and explain how glacial cycles work, and all of the atmospheric scientists and climatologists of his time rubbished the idea completely. They said that it couldn't happen. They said the ocean would absorb CO2 so quickly that it would never accumulate to the levels required, and they said that anyway the infrared absorption between water vapor and carbon dioxide would be saturated, and adding more carbon dioxide wouldn't do anything. And then over the intervening, then in about the 1930s, people started saying, you know, that there is evidence actually that perhaps carbon dioxide has been increasing. And then in the 1960s, they started realizing that actually the ocean can't absorb CO2 so quickly. It gets saturated in the upper level, and then it takes time to get from that upper level down into the deeper ocean. So then they developed more accurate spectrography equipment, and they were able to tell that actually carbon dioxide and water vapor don't overlap so much. They certainly don't overlap to the intensity required for saturation to be reached. So this is not some recent innovation that people have come up with for some political purpose. This is a scientific theory that for more than half of its life was ridiculed, attacked, and reviled. and it has survived that, and it is now the dominant scientific theory. And the suggestion, so the point I would like to make is that for 100 years, the top climate scientists and the top physicists, atmospheric physicists in the world have been looking at this project for decades, 8 hours a day, and they're much, much cleverer than me. And the suggestion that, well, they didn't think to include the sun, or they didn't think to include this, that, or the other, I think is misplaced. I think you're overstating the level of uncertainty. This is a hypothesis that has been destruction tested, and it has come through triumphant.
I have an objection on that. The thing is, the climate scientists in the 80s predicted that now we should be burned to death. That is not happening.
No, that's
they
nonsense.
predicted that. Al Gore said that the level.
Al Gore is not a
rise.
scientist.
Yes, but he was the major leading in the climate change.
No, let's stick to the science, shall we? Hansen in 1988 presented models of global warming that have actually been determined to be accurate. He got the aerosol forcing a little bit wrong, but you can't predict aerosol forcing. It's just something that's handed to you. Once you correct the aerosol forcing record, his prediction of the warming is spot on. So the claim that climate model predictions are inaccurate or were inaccurate in the 1980s is false.
I want to ask you one thing. So, do you agree that when the sun decided to sleep in the 17th century, there were a little ice age in the planet? In Europe, mostly.
Yes. Well, it's called the Little Ice Age, but it's actually more of a climate anomaly. Yes.
So that is with the sunspots or the climates of the sun, of how much sunspot is,
Yep.
how much energy is affecting the planet.
Yep.
Now we had an active sun in these recent years. So now they're saying that the sun is gonna go again into, they don't know how much, but it's gonna be very much little activity in the sun. So we will expect for the temperatures to drop.
Yes, but it won't. Yes, but we know how much that is, and we can do accurate forecasts of it. Your claim that we cannot accurately incorporate solar forcing into our climate models is again inconsistent with the results from the literature. The literature has demonstrated time and again that we can and do have the magnitude of solar forcing correct, and that we can where there is the suggestion that climate modelers forget to take the sun into account is so, I don't know, it's so insultingly childish. I mean, these are people who have been working for decades, 8 hours a day on this stuff. And if it occurs to you after a couple of hours of Googling that perhaps maybe solar variation is something worth considering, you can bet that they've gone off and done it in significantly more detail. And my suggestion to you is that if you want to tackle a scientific field of work, you might start by reading the textbooks on it. Rather than leaping straight into an interpretation of the literature. Because without the fundamental training, I don't think that you can correctly interpret the literature.
Okay, my point is that I'm just researching this and I'm giving new ideas. I'm not here speaking to the to go to be a scientist, to claim something. I'm just talking with you to have a conversation about this matter. Okay. I'm not saying anything. I'm just saying we maybe should look more for these other affected effects on the planet. The point is that all I hear in television, on YouTube, of all these activists is it's only the carbon. There is no mention in the sun. Yes, they are, of course. Nobody said that they are not looking, they are not calculating for the sun, but there is nothing. They are only claiming that the climate change is a major, is
But that's
only
not
by the carbon dioxide.
But that's not science, right? You're going by the statements of enthusiastic amateurs and not scientists. You can't attack a scientific field of knowledge or make accusations about it based on the understanding of some members of the general public. Surely, Conspiracy Cats earlier today published, did a presentation about a doctor talking about how viruses don't exist, and he's not the only doctor I've heard make that claim. The other one was claiming that it was down to electromagnetic radiation. But there are, we don't say that the medical profession as a whole is worthless because there exist some people who have some really weird ideas. It's and even less do we say that the medical profession is invalid because my uncle happens to have some strange ideas about how medicine works. The science is independent of what people say on YouTube.
That is correct, but the major thing that people are saying all the time, and that's how you inform public. Whoever you ask on the street, ask them about climate change, they're gonna say it's about the carbon dioxide.
Which
yes,
it is.
I dispute that.
Okay,
I'm saying there are many factors we don't know.
Well, in which, if that were true, if what you say were true, then it would not be possible for us to hindcast accurately. We would not be able, if we were missing some process and it was absent from our models, then our models would simply not agree with reality. We wouldn't be able to reconcile the observations to the models. And we can reconcile the observations of the models, which means that any processes we aren't including cannot be that big.
But the models.
I'm sorry to interrupt what has been a brilliant discussion, but we do sort of say we're always finished by 9, and we've not even thought about round 4 yet, and been getting some questions in. But it's been fascinating to listen to. Honestly, it really has, and I'm definitely going to be reviewing this for future Baldy Cat videos. And both of you taught me stuff that I had no idea about. So thank you very much for that. Creaky, is there anything you want to add before we dive into the questions?
Yeah, I think we should just dive straight into the questions based on the time we've got left, Kat.
Right. So, as promised, I'm just going to read out the questions that were posted under the round 1 community tab, and let's have a look. Okay. So, Boyan, you've already been told you're cute, so well done. WS says you both made well presented. You both presented well and made good cases. Wolverine 6668, I assume this one's to both of you, says, when will climate change or global warming become a mass extinction event? Have you both got an answer for that one?
Well, I have this is actually what got me into climate change, was the statement that we're already in it. It's inevitable, and humanity is going to be extinct within 100 years. And this came from Professor Frank Fenner, one of the preeminent social health scientists in Australia. Now, I'm hoping he's wrong, but but he said that in 2010. It's 2020, and we still aren't taking the problem seriously. At some point, somebody is going to make a statement like that, and they're going to be right. And it's going to be too late to do anything about it then. So this is a problem we have to take extremely seriously. And to be fair, he said that it was the combination of overpopulation and climate change. Now, the public health projections for India are that within 60 years, 60% of India is going to be too hot for people to do manual labor. The entirety of the Middle East is going to be too hot for people to live outdoors without air conditioning. So actually, we turn out to be ahead of schedule on reaching the temperature thresholds discussed in these articles. Now, if 600 million Indian people suddenly find that they cannot exist in the area that they're in, they're going to want to find somewhere that's more temperate. The nearest place that is going to be quite actually comfortable by that stage is actually China. China's going to do quite well out of climate change. But that suggests that China and India and perhaps Pakistan are going to be competing for resources. All three are nuclear powers. We already have a situation where China is damming Himalayan runoff and diverting it into China rather than letting it go into India. So the potential drivers for human extinction are not restricted to just the raw impacts of temperature. They are actually socio-political. Once people start running out of resources, it can spiral very, very quickly into a very, very ugly place.
Become very, very messy. Boyan, anything you want to say on that?
Yeah, I don't think that it's going to be a mass extinction, actually. The temperatures rise in the Middle Ages, and nothing dramatic happened. Nothing will dramatically happen, of course. We need to take this seriously. I'm not saying that. I'm not disputing that. We need to take it. We need to put less carbon dioxide into the atmosphere. That's correct, yes. But how are we going to deal with that first? And I'm saying that there need to be another alternative views on this problem that need to be looked, that need to be calculated. So for these doomsday, I don't know, predictions, it's common in Western culture to have doomsday predictions. You're gonna die in next 10, 100 or whatever.
Right, I think we are.
Can I respond to 2 points there? The medieval warm period, so-called, the Earth was about 0.1 degree warmer. We're heading to 2 to 5 degrees warmer in 200 years. So it's an entirely different hypothesis. We're already in a mass extinction.
Yes,
so
but we are heading. Doesn't mean that we're gonna go there. That's the point.
There is an extinction threshold. Animals above 3 kilograms are much more susceptible to extinction than animals less than 3 kilograms. I don't know how much you weigh. You look quite slender and young, but I weigh significantly more than 3 kilograms, as do most of the people I know.
I certainly do. Right. So we've got, I think, probably time for just one last question, then we're going to have to wrap it up. We've hit our magic 9 o'clock time. So, Creaky, do you want to choose the last question? Or
yeah. I did see one. Where was it? I don't know if this is a question. It's directed at Tony, but so Brainless Steel NL Tony wants you to suggest a good starting textbook for Boyan to look into so that he can be better prepared if he chooses to do this again.
So the textbook that I would recommend is called The Principles of Planetary Climate by Pierre Humbert. That's actually his surname, not his full name. It requires some quite sophisticated mathematics, but it's 600 pages worth, and it discusses things in quite considerable detail. It also discusses radiative transfer theory as applied to Mars, Titan, and Venus, and indeed the outer surfaces of Jupiter and Saturn. So it's a very generalized textbook. It's not related to Earth solely.
Excellent. But Boyan, I think, I just want to say a massive thank you to yourself. You've put a lot of time into the presentation you did. You've been fantastically civil. You've been up against a formidable opponent. I've had Tony on my channel before and learned a lot from him on glaciers, etc. He ripped apart, if you haven't seen Mind of God on a flat Earth debate not so long ago. He's he's an extremely formidable opponent. So well done for sticking in there, mate. How's it feel?
Yeah, it feels great. The opponent a little bit is angry, but it's okay.
I think it's been a well-mannered debate. I think it's been very well-mannered.
But the point is, I'm here to make a conversation. I'm not here. He's taking this too much personal, I think.
Okay. Well, I do apologize for that, and I will concede that I do get heated up about this because it terrifies me.
Yes, it terrifies me too, but we need to keep it a civil conversation here. If we both start arguing and yelling, that's going to be...
Okay, I apologize if my behavior, I apologize unconditionally for any behavior that was over the line.
Just for the record, that's not what I meant when I said formidable. I didn't mean it. No, I think the debate has been very civil from both sides. I think it's been very well informed from both sides. I think you've both prepared really, really hard. I would love, and I'm sure Creaky would feel the same, but I'd love to have both of you back on at any time whatsoever,
Yes.
So I've really, really enjoyed it and learned a lot. So thank you very much for coming. And you can read the chat and the polls later on, see what people thought of how you did. But I will pass you over to the Creekster. Hey,
the Creekster. Yeah, I get called a lot worse than that. I can promise you. And I just want to say as well, because we haven't had as much time as we generally would like to take questions from the audience, you can still leave questions underneath the first community poll, and I'm sure that Tony and Boyan will be able to spare 5 minutes to have a look at those questions, and maybe they can answer them, directly in the comment section on the community tab if that helps anybody.
Yep, happy to do that.
The later start tonight was all my fault. I take full responsibility for it, so I do apologize for that. But thank you very much again, and
I have a last thing to say.
Okay, let's go out on that. Go out on a high. Go on.
Yeah, thanks for Tony for the input, for the information. I wanted someone who is with a better knowledge in this to make a conversation, so I get informed and to make a conclusion out of it.
Okay. Thank you so much, Boyan. You were extremely civil, and again, I apologise.
It's not a problem
for making you for getting fired up at some point. And thank you, Creaky and Catz, for hosting us. Much appreciated.
Thank you. Thanks for coming on, and I'm sure we'll have you on again soon. Definitely, if you're up for it. Creaky, I'll leave you to say goodbye, sir.
Okie dokie, then that's exactly what I'll say. Thanks for watching, everybody. Don't forget to hit the subscribe button if you're new, and we will see you next week. Bye-bye.